Alright, we're going to talk about how we solve radical equations. So up until this point we've just talked about adding, subtracting, multiplying, dividing radical expressions, but in this case we're actually going to solve for a variable in an equation with radicals. So you should always follow the same steps when you're solving. So you always want to isolate one of the radicals, which means get one of the radicals by itself with nothing else on that side of the equal sign. And then, to get rid of the square root, we're going to square both sides of the equation, and then we'll just do some algebra to solve. Make sure you always state the restrictions. Recall that a square root cannot be negative. And then when you're finally done, you must check your answers to make sure they're not an extraneous root. So an extraneous root is a solution that you get, but it does not satisfy the restrictions. So for example 1, let's isolate this radical. Let's get the negative 3 and move it to the other side. So to do this, we're going to add 3 to both sides. This is step 1. So we have square root x minus 5 equals positive 2. And then we are going to square both sides. So when we square a square root, we get x minus 5, the square root disappears, equals 4. And we'll do a little bit of algebra, so we'll add 5 to both sides, and we get x equals 9. Okay, now before you go any further, make sure you state your restrictions. So if you look back at your square root, this was your square root. We have to make sure that this is greater than or equal to 0. We can't have a negative underneath the square root. So if we take a look at that, we say x minus 5 has to be bigger than or equal to 0. We add 5 to both sides. We have to say x has to be bigger than or equal to 5. That's our restriction. If we get an answer of 4, 3, 2, 1, 0, etc., it will not be solvable. Now in our case, we got x equals 9, which is totally fine. So let's go ahead and check. So we have the square root of x minus 5 minus 3 should equal negative 1. So if we plug in 9 for x and check our solution, we get the square root of 9 minus 5, which is the square root of 4. The square root of 4 is 2. So negative 1 equals negative 1. Okay. So now let's go to example 2. So for 2a, we're going to go ahead and subtract 6 from both sides. This is step number 1. So we get 2x plus 1 square rooted equals 6. Before you square it, let's get rid of this 2 in front. So let's divide 2 by both sides. So we get root x plus 1 equals 3. Then you can go ahead and square both sides. Notice I'm putting it in brackets to include all the terms. So we get x plus 1 equals 9. And now let's solve for x. So x would equal 8. Okay, by subtracting 1 from each side. Step 4 is the restrictions. So if I look at my square root, I've got the square root of x plus 1. So I know that x plus 1 has to be greater than or equal to 0. Which means that x must be greater than or equal to minus 1. I just subtracted 1 from each side. So my restrictions are x has to be greater than or equal to negative 1, which this works. So this would be an answer, but you must check. So check the left-hand side and the right-hand side. So 2 times the square root of x plus 1, well x is 8, plus 6 should equal 12. So we have 2 times the square root of 9 plus 6 should equal 12. So 2 times 3 plus 6 should equal 12. So 6 plus 6 is indeed 12. So our answer works. Okay. Robbie, did you have a question? so the last example, we have square root 3y minus 1, take away 2 equals 5. So let's start by isolating 3y minus 1 by adding 2 to both sides. So we get 3y minus 1 square rooted equals 7. Second step, we're going to square both sides. So we get 3y take away 1 equals 49. And then let's move 1 to the other side, so we get 3y equals 50. And finally, divide both sides by 3, so we get y equals 50 divided by 3, which I realize is a decimal number, so let's just leave it as a fraction. Okay, so step 4, we need to state the restrictions. So we know that we have 3y minus 1. So 3y minus 1 cannot be negative, so we say it has to be greater than 0. Add 1 to both sides. 3y has to be greater than 1. So y must be greater than or equal to 1/3. That is our restriction. Anything less than 1/3 cannot be a solution. So now let's check. Let's check our solution. So left-hand side, right-hand side. So we have the square root of 3 times 50 over 3, take away 1 minus 2, should equal 5. Luckily for us, these 3's go ahead and cancel. So we have the square root of 50, take away 1, take away 2, should equal 5. So the square root of 49, take away 2, should equal 5. 7 minus 2 does equal 5, so 5 equals